Welcome everyone to Electronics Online Lecture Series. In this, we will be discussing Integrated Circuits IC 555 from Paper 1, 6th chapter. In this, we will be studying IC 555, its pinout diagram and specifications, internal circuit diagram and explanation, a stable multivibrator, monostable multivibrator, and IC 555's applications. Let us begin with pinout diagram of IC 555. This is the pinout diagram. As you can see, there are 8 pins. Pin number 1 is for ground potential. Pin number 2 is for trigger input. Pin number 3 is for output condition. Pin number 4 for reset. 5 as control voltage, 6 as threshold level, pin number 7 for discharge, and pin number 8 is used for power supply voltage, that is VCC. The specifications of IC 555, it is a low-cost timer circuit. It can be connected in either 3 of the operating modes, that is astable, bistable and monostable. Supply voltage requirement is 3 volt to 18 volt and maximum load current capacity is around 200 milliampere. Now let us see the internal circuit diagram of IC 555. This is the internal circuit diagram of IC 555. As shown, there are 2 comparators. There is one RS flip-flop and at the output side you can see transistor along with the output condition. Input side, it consists of voltage divider arrangement where 3 5 kilo ohm resistors are connected in voltage divider arrangement. Each comparator has 2 input conditions. As you can see, first comparator has 2 input conditions, that is threshold level and one input is 2/3 VCC. Second comparator has again 2 input conditions. One is 1/3 VCC level and second one is trigger input. The output of comparators are applied as inputs, that is R and S inputs to RS flip-flop. The output of RS flip-flop has again 2 output conditions, Q and Q bar. Q bar is the total output of IC 555. Now this is the working of IC 555. The upper comparator, as I have mentioned, has 2 inputs. One is 2/3 VCC and another level. According to that, the output is given. Either the condition is set or reset. According to the conditions, the flip-flop's conditions can be, or we can say that the flip-flop will be in set mode or reset mode. If the output is either it is Q or Q bar. If the output Q is high, then the transistor, that is the base input of the transistor, is high and transistor will saturate. In that condition, the output Q bar, another level, is the total output of the IC 555. IC 555 as monostable multivibrator. This is the circuit diagram of monostable multivibrator in which IC555's pin number 4 and pin number 8 are connected to plus VCC. Pin number 7 and pin number 6 are shorted together. Resistor capacitor network is connected in between pin number 4-8 and 7-6. R and C are connected together and midpoint is connected to pin number 7 and pin number 6. Pin number 3 is for the output condition. Pin number 2 we can apply trigger input. Pin number 1 is connected to the ground potential and pin number 5 is control voltage which can be generated with the help of capacitor. These are the waveforms. While charging and discharging of the capacitor, we can get the output. Okay. So when the input, that is trigger, is applied accordingly, we can observe the output condition. Working of this multivibrator, it totally depends on charging and discharging, and as well as the input voltage which is applied. According to that, 2/3 and 1/3 VCC is generated which can be applied to both the comparators, and in turn either comparator first will be in working condition or second will be in working condition. So RS flip-flop changes its state and we can get the output. The total width of the pulse is 1.1 RC. A-stable timer. This is the circuit diagram of IC555 in A-stable mode. Here also you can observe that pin number 4 and pin number 8, those pins are shorted together and applied to plus VCC. Now here the change is pin number 6 and pin number 2, that is trigger pulse. These two are shorted together and they are connected to the network which consists of 2 resistors and 1 capacitor. If you observe, pin number 7 is connected in between 2 resistors. Pin number 1 is normally connected to the ground potential and 5 is the use for control voltage. Pin number 3 output point, so we can collect the output across pin number 3. The output waveform shows that again depending on charging and discharging of the capacitor, we can observe the output waveform. Now this is the working of A-stable 555 timer. Now here in this case the duty cycle, that is W upon T, that is the main thing. Duty cycle depends on width. Width is nothing but only on time, and total time period T is equal to T on plus T off. It also depends on the values of 2 resistors. So D is also equal to R1 plus R2 divided by R1 plus 2R2. This formula is required while designing the circuit. Then we can find out the total frequency. Frequency can be calculated with the help of formula as 1.44 divided by 1 plus 2R2 into C. The total time period is equal to T on plus T off, and it depends on width of the pulse also. So while designing the circuit, T1 is equal to 0.693 in bracket R1 plus R2 into C, that is also called as charging time, and T2 is discharging time, is equal to 0.693 R2 into C, with the help of which we can find out the output frequency. Now are the applications of this IC555. Can be used as monostable timer, A-stable timer, voltage controlled oscillator, ramp generator, pulse amplitude modulator, also known as PAM, pulse width modulator, PWM, pulse position modulator, PPM, frequency shift keying, FSK, and bistable multivibrator. So in this way, we have studied IC555's internal block diagram, specification, its uses, its modes, and its applications. Thank you.